Hi there, I'm Sophia, and in today's lesson we're going to be talking about solving simultaneous equations using a method of elimination. So firstly, let's talk a little bit about simultaneous equations, what they are and why we use them. I've got an example here on the left of a pair of simultaneous equations. We can see that in each equation we've got an x and a y, and we don't know what they are, there's two unknowns. If we consider this first equation, I'm just going to label it equation 1 to make talking about it a bit easier. And let's label the second equation as equation 2. If we consider just equation 1, we can see there's two unknowns, and no matter what we do, no matter what algebra tricks we do, we can't work out what the values of x and y are. There's just not enough information. That's where the second equation comes in. When we've got two equations and two unknowns, we can work out what the two unknowns are. And you can have any number of simultaneous equations, as long as you've got as many equations as you've got unknowns. There's lots and lots of ways that you can solve simultaneous equations. One of the easiest and simplest is elimination, and that's what we'll be talking about today. So what is elimination? Well, the clue is kind of in the name. What we're going to do is try and eliminate one of the variables so that we can work out what one is, and then we can use the value of that to work out the other one. So to eliminate, we're going to basically multiply one of the equations by a factor, and then we're going to subtract it from the other, so that we eliminate one of the variables. That sounds kind of weird, but it's just simple addition and multiplication and subtraction, which we've done before. So if we look at our equations here, we can see there's an x by itself in the first equation, and in the second equation we've got a 2x. So I'm going to try and eliminate this x. If I multiply this x here by 2, I'll have a 2x, and I can then subtract it from this, and that will get rid of my x's completely. But we know in algebra, whatever you do to one side of the equation, you've got to do to the other side of the equation. So I've got to multiply the x, the 5y, and the 16, all of them, by 2. So let's do that. 2 times x is just 2x. 2 times 5y, well that's just 2 times 5, that's 10y. And finally, 2 times 16 gives us 32. So now we've got equation 1 multiplied by 2. And this is the same as equation 1, it's just multiplied by a factor of 2. So the values of x and y haven't changed, and the overall value of the equation hasn't changed. We can now subtract equation 2 from equation 1. So let's write it out underneath, because that always makes it a bit easier. We've got 2x plus 3y equals 18. And this is exactly the same as any sort of subtraction. We're just doing it within an equation. So let's subtract this, and I can put it around brackets around it, just to remind us we've got to subtract everything. So let's do this last right hand side first. 32 minus 18, that's 14. Now let's look at our y's. We've got 10y minus 3y. That's just 10 minus 3. That gives us 7y. And now over to the x's. Well, 2x minus 2x, that's just 0. So we've managed to successfully eliminate the x. So now we've just got this equation here, 7y equals 14, which we can easily solve by dividing both sides by 7. 7y divided by 7 is just y, and 14 divided by 7 is 2. So there we go, we've worked out y equals 2. Now that we've got y equals 2, we can work out what x is by substituting this back into one of the equations. So I'm going to substitute it back into the top equation, equation 1, but it really doesn't matter which one you choose, completely up to personal preference. So we've got x, which we still don't know, and then we've got plus 5y. But now we know that y equals 2, and 5 times 2 is 10, so we've just got x plus 10 is equal to 16. So now we've got one equation with just one unknown in it, just x we don't know. So we can work out what x is by subtracting 10 from both sides. X plus 10 minus 10, that's just x. And 16 minus 10 is 6. And there we have it. We've worked out that y equals 2 and x equals 6. And there is a way you can check your answers, just to be double sure. And you can do this by substituting the values of y and the values of x back into the equation. So seeing as we used equation 1 to work out x, let's substitute back into equation 2. So we've got 2x plus 3y equals 18. But we know that x is 6, and 2 times 6, that gives us 12. Then we've got 3y, but we've worked out that y is 2, and 3 times 2 is 6. And 12 plus 6, that just gives us 18, which is the same as what this equation up here says, so we've confirmed that it's right. And we already know that the top one is right. X is 6, so 6 plus 10 equals 16, and that's correct as well. So we know that we've got the right answers. So this is just a simple example of solving simultaneous equations by elimination. And the key point here, just to summarise, is to try and make sure that you've got coefficients of one of the variables the same. So here we made the coefficient of 2 the same so that we could eliminate x. And it doesn't matter which one you can do x or y or z or whatever it is. Just make sure that the coefficients are the same so that when you subtract you get 0. And then once you've eliminated it, it's very easy to work out what the other variable is. And that's all. Thank you very much for listening.